Okay, this is Mr. Weideman, Lafayette High School, AP Physics, UT Quest, homework help problem on simple harmonic motion. Okay, this one, they give you a mass on a known spring constant K and tells you that it oscillates vertically according to this equation, which is just our displacement equation versus time for a harmonic oscillator. And this problem is much more math than it is physics. Okay, I cut and paste this right from our notes. Okay, what these different parts of the equation are. And part one says they want omega. They want the angular frequency. Well, if we look over in this part right here, we have this frequency equation, plug and chug, and then take this frequency, plug it into our omega equation, part one. You're done. And kind of need this for follow one, but not really. All right, so part one should be a no-brainer. Okay, let's go on to the next part. Okay, so the next part is they give me a velocity at a certain time. All right, so let's go to the derivative of that equation. And you don't have to take the derivative. We already did this in our notes. So our velocity versus time equation is this guy. All right, and so what we have all this information in here. So we need to find amplitude is really our unknown. Now I'm going to admit solving this is a bear. Okay, but if you do solve it, you end up feeling like a real trig beast. Okay, let's look at what happens in here. Okay, so since t equals 0, that term cancels out. So the equation says, well, I want to take the cosine of the inverse sine of theta naught. Okay, well, theta naught is the inverse of dy over a. All right, and I want the cosine of theta naught. All right, so you have to think back to your pre-cal and trigonometry day, and let's see what they're giving us, and let's see what they want. Okay, theta naught is side opposite over hypotenuse. Side opposite is given, it's the displacement in the y. Amplitude is the hypotenuse of the triangle. All right, now I need the cosine of that angle, theta naught. All right, well, I'm going to need side adjacent, which is my displacement in my x, which I don't know. But what I can use, I can use Pythagorean theorem and get a statement or a mathematical expression for dx in terms of what I do know and the variable. Okay, so let's go back to our trig. What is the inverse sine of dy over amplitude? Well, that is theta naught. Okay, so really what this is telling me to do is I want the cosine of theta naught. All right, well, what is cosine? It is adjacent over hypotenuse. Okay, so my adjacent is this very bad looking thing, and then there's my hypotenuse. All right, so let's put that in. And that is the cosine of theta naught, if I knew all that stuff, which I do, except for amplitude. The rest is algebra. A little messy, but the rest is algebra. And those cancel, and I'm going to divide both sides by omega, then I'm going to square both sides, then I'm going to move, isolate amplitude, and take the square root of both sides, and I get this garbage. Ouch. Okay, bear with me. There is an easier way. Okay, this can be done a lot simpler just using conservation of energy, because they give me a velocity and they give me a position. So that means that this side of my conservation of energy, I know all this stuff, and I can solve for this. All right. So my energy at any point during the opposite, by conservation of energy, the energy, total energy, is the same everywhere. Okay? And I know the kinetic energy because I'm given the velocity. I know the potential energy because I'm given the position. And then I know that it has to equal the total energy at the amplitude. Okay, so the only unknown I have in this expression right here is my amplitude. Okay, and so I can solve for amplitude, and that is that part. Okay, what's next? Part 3. Part 3, plug and chug. All right, the displacement they gave me, the amplitude I just found, put it in there, plug and chug, and I can get theta naught. Make sure you're in, do they want it in degrees? I think they want it in degrees. Yeah. All right, make sure you're in the degrees mode. Okay, so once I get part 3 and part 2, then I know every single thing in this equation. And so I just plug in the time that they want, got theta naught, got omega, got amplitude. So I've got my full expression or my function for vertical displacement versus time. So that is seriously a plug and chug, assuming that you got parts 1, 2, and 3 correct.